Most people still talk about agents as if the main breakthrough is better prompting. Better prompts help, but prompting is not the real operating system of an agent. The real system is the loop that keeps working after the first instruction lands. A prompt can tell the agent what to do. It cannot by itself guarantee how the job starts, what evidence gets collected, what actions are allowed, or whether the work was actually completed. That is why polished prompting still produces fragile agents. Take a tiny example. You tell an agent, fix the bug. That sounds useful, but the instruction hides every operational detail that matters. Which bug, where, under what constraints, with what tests, with what stopping rule, and who approves a risky change. So this lesson starts with one practical claim. The future of useful agents is not only better prompts, it is better loop design. If you design the loop well, the prompt becomes a starting point instead of a magic trick. First, we will separate two ideas clearly. Prompt means what the agent should do. Loop means how the agent keeps working until done. That difference sounds simple, but it changes how you design the whole runtime. Second, we will walk the responsibilities a real loop owns. How the agent starts, what context it gathers, what actions it takes, how it verifies work, when it repeats, when it stops, and when it asks a human for help. Third, we will keep the explanation grounded in engineering work instead of abstract AI hype. A useful agent has to behave well inside real systems with real risk, not just produce an answer that sounds impressive in a demo. And by the end, you should be able to compare a weak prompt like fix the bug with a stronger loop, such as find the bug, reproduce it, fix it, run tests, verify the fix, and stop after 3 failed attempts. A prompt is an instruction. It expresses a goal, a request, or a constraint in language. That matters because the prompt tells the model what problem space it should work inside. But a prompt is still only the beginning of the run. A loop is the control flow around that instruction. It decides what happens next, what state gets recorded, which tools are available, how results are checked, and whether the agent keeps going or stops. The loop is the runtime discipline around the prompt. That is why 2 agents can receive the same prompt and behave very differently. One might guess, wander, and stop early. Another might collect evidence, choose careful steps, verify outcomes, and ask for approval before doing anything risky. When teams focus only on prompt wording, they are often tuning the surface and ignoring the operating model. When teams design the loop, they shape the behavior that actually determines reliability, safety, and useful completion. A strong loop starts by turning a vague request into structured task state. Not just fix the bug, but which service, which environment, what repository, what urgency, what time budget, and what level of change is allowed in this run. Then the loop gathers context before acting. It may read the ticket, inspect logs, load recent commits, check test status, or review deployment history. The point is simple. Act on evidence, not on the first story the model invents. Good loops also bound the working surface early. Maybe the agent can inspect the codebase, but not merge. Maybe it can run tests, but not deploy. Maybe it can suggest a patch draft, but must escalate before touching production systems. Only after the task is normalized and the context is loaded should the loop choose the first step. That first step should be small, checkable, and reversible when possible. Senior engineering teams do not start with the most powerful action. They start with the safest informative move. When the loop takes action, it should do it one step at a time. Search the error, reproduce the issue, open the failing file, make the smallest reasonable change, then observe what changed. Action without observation is how agents drift into fiction. This is where tool design matters too. A mature loop does not give the model one giant do-anything tool. It exposes bounded tools such as read logs, run unit tests, apply patch draft, or open review note, each with clear constraints. Right actions should come later, after enough evidence exists. In the bug example, changing code before reproducing the issue is usually the wrong sequence. The loop should earn the right to act by proving it understands what failed. After every action, the loop should update state. What was tried, what was observed, what remains uncertain, and what the next best step is. Without state, repeated steps start to look like progress when they are really just expensive confusion. Verification is not a cleanup step at the end. It is part of the loop itself. After the agent changes something, it should check whether the change actually solved the problem, whether tests passed, and whether new failures appeared somewhere else. In bug work, that often means reproduce the issue first, then verify the fix against the same condition. If the bug cannot be reproduced, the loop should say that clearly instead of pretending the fix is proven. Confidence without evidence is not engineering. Sometimes verification fails because the last action was wrong. That is where repetition belongs. The loop can try again, but it should retry with rules. Change the hypothesis. Gather missing context. Attempt a smaller fix. Do not repeat the same blind move forever. One of the healthiest loop behaviors is admitting failure cleanly. If the evidence stays weak or 3 careful attempts still fail, the loop should stop, summarize what it learned, and surface the blocker. A trustworthy agent does not hide uncertainty behind more output. A strong loop repeats only when there is a reason. New evidence arrived, a test exposed a narrower failure. A safer alternative action exists. Repetition should be driven by learning, not by momentum. The loop also needs explicit stop conditions. Goal reached. No safe next step. Time budget exhausted. Attempt budget exhausted. Human approval required. Those are not annoying details. They are the boundaries that stop agents from turning into runaway automation. Human escalation should be designed in, not treated as failure. If the loop reaches a risky migration, ambiguous incident, destructive command, or missing permission boundary, asking a human is a success path. It means the system knows where automated confidence should end. When the loop stops or escalates, it should leave a clean summary behind. What it was asked to do, what context it gathered, what actions it took, what it verified, what remains unresolved, and what decision the human needs to make next. Now compare the two patterns directly. Weak prompt. Fix the bug. That sounds efficient, but it hides the operating model. It gives you no visible discipline for evidence, no verification path, and no explicit stopping rule. Strong loop. Find the bug, reproduce it, fix it, run tests, verify the fix, and stop after 3 failed attempts. Notice how the work is no longer vague. The runtime has a sequence, a verification method, and a boundary for when not to keep guessing. That is the bigger lesson for agent design. Prompts describe intent. Loops create behavior. If you want useful agents, spend less time pretending. Prompt wording alone will save you, and more time designing how the system gathers evidence, acts safely, verifies, repeats, stops, and escalates. If this was useful, subscribe for more practical cloud and AI engineering lessons from Trustscrin Cloud and AI Engineering. We can keep going with tool calling, memory, approval flows, and how to build agent systems that behave more like disciplined engineering workflows than magic demos.